Hello all. Today let's see a question from Mechanical Engineering Paper 1 from GATE 2019. So this is question number 38. So according to this question, you are given a truss system like this with two supports at the end, and you are given this force. So what are you supposed to do is you have to find what is the magnitude of force in kilonewtons in the member BC. Okay, so this member you have to find BC, you have to find what is the force. So this is a truss problem, and you can check out about it more in details in NPTEL lecture Engineering Mechanics by Professor Manoj from IIT Kanpur. So let's go into the deeply into the problem. So before going into the problem, let's see a useful information here. If you have three members forming a truss joint and two of them are collinear, then the third member is zero force member, provided there is no external force or support reaction at that joint. So according to this, if you consider joint B as shown here, and you have AB and BC which are collinear, that means the force in the element or the member BD is 0. So the important thing to notice is the joint under consideration is B, and there is no force or support reactions at that point. That's how you identify this member. So let's go further into the problem. If you notice, according to the principle I just explained, you can see that you are having a B joint like this. So it is having a support reaction here, but not at the joint which is under consideration, right? So you can see that these two, that is A, okay, this is B, this is C. So your AB and BC are collinear, therefore the member, yeah, so this is D. So the force in member BD is equal to 0. So this is your zero force member, so you can remove this. So you can draw this equivalently as this way. So you are having a symmetric system like this. You are having a force from top like this. Okay, so now important thing to notice here is that your force, whatever be it, is actually, since the system is very much symmetric across this axis, it will get equally distributed onto these support reactions. Okay, so you can straight away write that your reactions at A is equal to reactions at C, since the system is very much symmetrically loaded. So that means when you actually you can say that your 10 is getting equally distributed. So on each side you will get 5 kilonewton as the force at each support reaction. So let's think about it further. So if you check at point BC, you are having like this. So this is your B, okay, and yeah, D. Now what are you having here? A support reaction RC, which is 5 kilonewton. So now how you can draw the forces here is like at this point C, you're having so how am I drawing this direction is your RC is going to be up. So if you resolve this along this direction, your force vector is going to be like this. So to oppose that, this member, that is your member CD, will oppose that. So that's how you get the direction to this. Now if you resolve the force along this direction, you will get an arrow which is pointing this direction, right? When you resolve this, so that means your member BC should have opposite direction. So that's how you get all these directions that I have just drawn. So now you are having here 45 degree, so you are going to have 45 degree here also. So now if you equate the vertical forces at this joint, okay, that is net force is 0. So let's say this is FCD, this is FBC, okay. So what are you going to get? FCD into cos 45 minus 5 is equal to 0. So FCD is equal to 5 by cos 45, which you are going to get is 5 root 2, right? Let's take along x direction right now. So what will we get is, if you look at this particular figure, we can write net force along x direction is 0. That means you will get FBC, which is negative direction, plus FCD sine 45 is equal to 0. So when you actually solve this, you are going to get FBC is equal to FCD sine 45, which is again 5 root 2 into 1 by root 2. If you see carefully here, the angle here is 45 degree. Therefore, even if you take the cos 45, the answer would have remained the same according to this particular figure. So anyway, your final answer is FPC is equal to 5 kilonewton. So this is your final answer. So if you see, the question was to find what is the force in this member. Since the system was very symmetrical, you could solve it very easily, and analyzing this one joint was enough to find the answer for this particular problem, and this joint particularly. So thank you.